Hello science enthusiasts, welcome to the new episode of Beacon Bin Science. Today in this video, we are going to discuss some of the very important name reactions. You may encounter these name reactions during the industrial interviews or during some other competitive interviews. Suppose you have completed your masters in from organic chemistry and now you are looking for some industrial job, or maybe you have completed your PhD degree and now you are looking forward to get into industry. So now the one thing that you have to crack to get inside the industry is to give the interview. The majority of the questions may come from these reactions. Why I'm saying this, because I have faced many interviews and I have seen that the whatever the pattern these companies follows is basically they start from the basics reaction, and when you are able to give them the correct answer from that basic reactions, name reactions, then they go on for the next step. That means they ask you some hard name reaction which is difficult to remember, like that. So conversions and name reactions, these are very important for the industrial interviews, so you have to remember these name reactions. Apart from that, they can ask you questions from NMR point of view, from mass spectroscopy, from IR spectroscopy, depending upon in which industry, which sector industry you are giving an interview. But the basic thing, if you are an organic chemist, you should know name reactions. That is what they are expecting from you. And some of the name reactions are very common. They will definitely going to ask you from the questions from any of these name reactions. So we will go through one by one what are the major name reactions most of the time interviewer asks you during the interview. I'll put the light one by one into these reactions. So number one, what we'll see is the Grignard reaction. This Grignard reaction is very important, because this Grignard reaction is helpful to convert any to make carbon-carbon bond. You can see here there is a carbon-carbon bond formation happens with the Grignard reaction. And apart from that, from converting the alcohol, converting aldehyde or ketone to alcohol, this reaction is very important for this purpose. So as we can see here, first what we do, we take some halide. This is X resembles some halide like fluorine, chlorine, bromine, like that. And this R is any alkyl or any aromatic compound, carbon compound. So first we treat with the magnesium, this alkyl halide, and then make it RMgX. This magnesium inserted between this R and X group. Now with this you can see here this Mg, this is a metal, and this R, which is a carbon. So carbon is more electronegative compared to metal. Because of that, there is a partial negative charge over the carbon R group, and there is a partial positive charge over this magnesium. Because of this partial negative charge over carbon, it becomes little bit more electronegative. Because of its electronegativity, it can attack to electrophilic group. Now here if we see the other reactant, here this carbon, this place is electrophilic in nature because oxygen is attached to this carbon and with the double bond. Now this double bond can be shifted towards oxygen, making this place partial positive. Because of this partial positive place, this becomes more electrophilic. Now this nucleophile can attack to this electrophile, and here this carbon can attack to this place, and resulting into this oxygen double bond get opened into a single bond, and this O minus will form. So in this way there is the formation of the alcohol group by using Grignard reagent. Now again, as I have told you all earlier, we can see it here the mechanism clearly, that RMgX, this R is having a partial negative charge and Mg is having a partial positive charge. Here also I have already explained that this carbon is having a partial positive charge because of presence of double bond oxygen attached here. The bond will shift partially towards the oxygen. Because of that, electropositivity will generate, and because of that, electrophilic character is generated to this carbon. Now this nucleophilic carbon attack to this electrophilic carbon, forming a bond, and here this oxygen, which is having a partial negative charge, will attract towards this partial positive Mg, and then form this kind of a intermediate. After this intermediate, there is the complete conversion of this compound. This is a complex formation, and This is how there is a presence of acidic acid in this group in this reaction, because of which the MgX will be removed and H will be abstracted by the oxygen and forming into conversion into an alcohol. This is how this Grignard reaction takes place. Now, from interview perspective, the interviewer may ask you which name reaction is helpful for converting the aldehyde or ketones into alcohol. One thing he can ask you. Another thing he can ask you that what are the name reaction in which you can use the alkyl halide and convert into an alcohol. Like that, he can ask you, or directly he can ask you what is the Grignard reaction. So like that, he can ask you these type of questions, and you have to know each and every step of this reaction, because he may give you a paper and pen and he will ask you to write the mechanism of this reaction. Now moving on to the next reaction, which is very important reaction, that is Friedel-Crafts acylation reaction. As you can see here, acylation. So acyl group, this one, R C double bond O. This group is acyl group. So attaching this acyl group to aromatic compound is what Friedel-Crafts acylation reaction. Now, for this reaction, this is very important reaction. Many of the time, interviewer asks you how you can attach the ketonic group, how you can convert the simple benzene into a ketone, like any ketone which is having any group here. So, like that, how can you convert it? So, best name reaction for conversion of this type of conversion is Friedel-Crafts acylation reaction. Now, for this Friedel-Crafts acylation, the very important thing which should be you should take care of is the presence of this Lewis acid. So you have to remember that Lewis acid is that group which is having an electron deficiency. We can see here this aluminium, which is attached with the 3 chlorine group, is actually the electron withdrawing, this chlorine group is withdrawing the electron from aluminium and making this aluminium metal very less electron dense. Because of that, this becomes a Lewis acid, because it is electron deficient. So any group like BF3, all these are electron deficient. So this Lewis acid, in presence of this acyl chloride, when reacted with the aromatic compound, it gives the aromatic acyl group, right? So now how it take place? The first step is that this chlorine is having a lone pair of electron, which gives its lone pair of electron to the aluminium, which aluminum chloride. Why? Because as I told you, this is actually Lewis acid, which means it is electron deficient. So this gives electron to this place and make a complex. And this complex, because of the formation of this complex, this chlorine will leave to this play, becomes a good leaving group and leaves the this acyl group. And while leaving, this oxygen lone pair acts as a driving force and gives its lone pair back to the system, and this chlorine will remove. Because of that, this oxygen gives back its lone pair, making it a triple bond. But now the triple in this triple bond, the oxygen is having a positive charge, which is not possible. As you know that oxygen is very electronegative and it can't survive with the positive charge on its top. So what it do? It will this system become very reactive. Now, if this aromatic system, if it comes in close vicinity to this intermediate, what happens? This aromatic compound give its electron pair to this carbon, and the triple bond shifted the electron towards oxygen, which is a positive charge. Because of this, it shifted towards oxygen, and like that, the electrophilic substitution happens, and there is a double bond formation, and the carbon and this carbon bond take place. This intermediate, this ionic intermediate, it will again attracts this hydrogen present at this place, attract it and leave the HCl group outside. With this hydrogen, again push back the electrons towards this system and making it aromatic. Like that, this what you call benzyl acyl group formation take place, which is ketonic kind of a conversion. So in this way, you can convert the aromatic compound into a ketone. Now the third reaction. So coupling reaction, any kind of a coupling reaction, Suzuki reaction, Heck reaction, Sonagashira coupling. These are so many different kind of a coupling reaction. Out of them, he can ask you any of the coupling reaction. Now what important is, you should know what is coupling reaction and how it is carried forward. This is very, very important. I am telling you again and again, because coupling reaction is the fundamental of most of the industries in chemistry, chemical industries, which are working on the organic chemistry. So they do this coupling reaction oftentimes, and they wanted you as a chemist to know about this coupling reaction. So what are this coupling reaction and how it works, and what are the questions they can ask you is, in this coupling reaction, the palladium catalyzed. This reaction is actually a palladium catalyzed carbon-carbon connection, right? So there is one. We are basically talking about this Heck coupling here. So what happens in this Heck coupling? Carbon and halide group is attached here, and this halide group, organohalide group, in presence of this double bond, this double bond can be attached with any R group, H group, aromatic group, CN group, or any other electron withdrawing group. In presence of this, when palladium catalyst is used, it can connect this R with this carbon, directly with this carbon. So here the importance of this reaction is that we can directly connect the carbon and another carbon directly without using any other substance apart from this palladium catalyst. Here the Z group can be changed depending upon the which name reaction you are going to do. Suppose Suzuki, in the Suzuki this boron is here. Boronic ester, boronic acid can be used here in place of Z. But in Heck coupling, that can be any R group, like any alkyl group, any aromatic group can be here, and also X can be here. So this, but here the RX, this halide group should be there for this coupling reaction. Now, what happens in this reaction? The most important question what they ask you is how you put the Suzuki coupling reaction. So you have to tell him that first we have to take this starting material 1, starting material 2, put it in a seal tube, keep it in the seal tube, and after that add solvent and then degas it. This is very important. That is what they wanted to know you, that whether you know this degassing or not. So we have to do the degassing for this conversion, this reaction to be happen. We have to do the degassing, and they may ask you what is degassing. So it means that we have to purge this reaction with nitrogen or argon gas. I have made a separate video on how to do the degassing. What is degassing? I have made the video. You can check it out. It might be coming in the icon on the top of this video. So you can click on that option, and then you can watch this video later on. Why? Because this palladium which we are going to use get oxidized because of the presence of oxygen, and to avoid this oxidation, if this gets oxidized, this palladium get oxidized, the reaction will not take place. So to avoid this oxidation, we have to use the nitrogen or argon to remove out all the trapped oxygen inside the solvent or in the neighboring environment, also inside the seal tube. We put this reaction in the seal tube. After this degassing, we put the base, and then we put the finally we put the palladium catalyst in a very catalytic amount. That is why we are saying catalyst, because it is used in a catalytic amount, like 0.01 equivalent or 0.001 equivalent, like that it should be used. So after putting this thing, we seal the tube and put it around 80 to 100 degrees Celsius and keep it uh, for 2 to 4 hours, depending upon the reaction which we are performing. So like that, and after that, when the reaction completes, we filter it out using the Silite filter. Whatever after filtration we obtain, we evaporate it and then wash it, or do the workup, and then we get the compound. Like that we do it. So this is the mechanism. We can see it here. This palladium we use at a zero electronic state palladium. Like for example, we can use PDOAC whole twice, or we can use PDPPS3 whole twice, or PPS3 whole 4. Like that, we can use many palladium catalysts available in the market. So then, with that, we add this RX group, alkyl halide or aryl halide, whatever it is, and then this get connected in the oxidative addition, in the form of oxidative addition, and form RPD and PDX bond. Like after that, this coordination reaction happens here. After that, this get connected to the double bond, because palladium is electron deficient, and this double bond gives its electron to this and form a coordinate bond. And then here the electron shifted to this place, and here this R shifted to this carbon, like that, and the R and C connection happens, and this carbon and palladium bond connection forms. Like that it forms. Now in the end step, this step is known as insertion, and after that the final step is elimination, and H bond, like that it will form, and finally again it will convert into palladium 2 by removing this HX compound. Like that this cycle goes on. If we see the example, we can see it here. There is a aromatic group which is R and X. This group is RX group, and here we have seen that this is carbon carbon, and here this group is the Z group. We have used the palladium, which is a 1.5%, which means very less amount of the palladium we have used, 0.015%, 0.015 molar compound we have used of this palladium catalyst, and this we have used as a ligand, and 1.1 equivalent of base. Dioxane we have used as a solvent, and we have kept it at 120 degrees Celsius for 24 hours. This reaction convert into this carbon and carbon bond formation results. After that, one more very important example is Buchwald coupling. This is also a coupling reaction, but this is majorly used for carbon and nitrogen connection. Initially, we have checked in Heck coupling and Suzuki coupling the carbon-carbon connection, but now here carbon and nitrogen connection is the majority why we use the Buchwald reaction. So you can see it here, the same mechanism and everything is same, but you can see this example. There are so many examples. So for connecting this carbon and nitrogen, we use this Buchwald reaction. Here also everything is mostly same. We use the palladium catalyst, we use the ligands, we use the base, and we use the solvent, and also we do the heating. So like that, whatever we have learned in the Suzuki coupling and other coupling, here also Buchwald reaction also uses the same thing. In majority of the coupling reaction, the Suzuki or head coupling, we generally use the water, but in Buchwald we avoid the water use. So this one you can reply if somebody asks you like that. And also here the carbon and nitrogen bond formation take place. Okay, and now we can see it here again. This palladium gets inserted here. There is conversion of palladium 0 to palladium 2 state, and then this nitrogen gets here attached here, and then reactive elimination take place here finally, and the palladium 0 state again we will get it. In the end, what I will say you, there are so many other reactions that they may ask you in the interview, so you have to learn each and every reaction. There is no shortcut for that, but what I am telling you here in this video is that these are some of the major name reactions which you should know. Suppose you are not suppose interviewer asks you some question and some name reaction and you are not able to answer it, that's fine, that's completely fine, because nobody knows each and every name reaction. But these are some of the basic name reaction that you should definitely know, so that it will give a good impression to the interviewer that okay, he knows a lot about it, but some portion he doesn't know. That's it. So don't give too much stress to the things which you don't know in the during interview. Only focus on those things which you know very well. Just give them a very clear idea that whatever you know it perfectly. That is very important. So now one of the important book that I would suggest you to go through for your interview if you wanted to improve your name reaction, and this book you can get the PDF also, and you can buy it online also in this book. So this book is written by J.E. Jackley, and this is the Springer publication. They have published this book, Springer publication, and the title of the book is Name Reaction: A Collection of Detailed Name Reaction, the Detailed Reaction Mechanisms. This book you can prefer for your preparation of name reactions. So you can see in this one, there's all the name reactions from A to Z, whatever name reactions are available, it is there in this book. So you can go through with this book for your interview. And if you wanted to know some trick and tips about the interviews, you can comment me down, and I'll try to respond to those comments, and I'll make up separate videos to whatever the queries you might have. So that's it for this video. See you in the next video.